Bruce Kuwabara is a partner at KPMB Architects in Toronto and the partner in charge of the Manitoba Hydro Place project in Winnipeg. And that's the building that is the winner of the 2009 Council on Tall Buildings and Urban Habitat Best Tall Building in the Americas. Congratulations on the award.
Thank you very much.
Tell me about this project and what makes it so distinctive.
I think what makes it distinctive is that we had quite an incredible design process that was really involving the client and an integrated design team. And we also had an energy engineer from Europe. And I think that's the interesting thing. So you have essentially Canadian consultants, engineers, architects, the client's Canadian, based in Winnipeg, Hydro Corporation. But we had TransSolar, who are based in Stuttgart, sort of really monitoring the performance of the building in real time as we were designing it, which is very, very difficult.
And one of the things that's so amazing about this particular building is this is a sustainable building that breathes, and it actually has winter and summer modes of operation. And Winnipeg is not a climate for the meek, because the temperature range there is minus 35 degrees to plus 35 degrees Celsius.
Extraordinary
which is about 30 below zero to about 95 degrees. Just generally, what are the challenges of designing for such a wide range of climatology?
Well, I think you have to really look at the climate in detail to really understand what the potentials are to really develop the passive systems. And so what we know about Winnipeg is it has the most sunlight of any major Canadian city. It also had a predominant windrows that showed the winds coming from the south, which is actually counterintuitive in Canada. We think they come from the northwest, Arctic winds. But the windrows actually shows the wind coming from the south, and that really helped generate the energy concept. We decoupled heating and cooling from ventilation. That's a key strategy. So we have the largest application, geothermal application in the country, 280 holes drilled 400 feet at 15-foot centers below the entire site. Our slabs, which are 10 inches, have 1-inch diameter tubing in them that keep them at 20 degrees Celsius no matter what's happening outside. And it's the combination of the fresh air coming in through the lungs of the building, which are the atrias that face south, and the displacement ventilation, and the dynamic slabs that create the comfort level. And then when you throw into that, I mean, the key thing I learned was the building envelope is so critical to achieving these kinds of energy reductions. We essentially have a triple glazed building. We have double walls on the east and west facades and triple glazing pretty much everywhere else. And it's the envelope which really produces, I think, in consort with the natural ventilation and the geothermal, the comfort levels for both daylighting and heating and cooling. And, you know, I've learned a lot on this project. I mean, one is that, you know, if you really want to reduce energy consumption, you really have to attack heating and cooling loads and electrical lighting loads. And in those two, you might have 65% of your energy budget. We're reducing energy over 60% below our Model National Energy Code building. And that's never been done before, not at this scale.
I was going to ask you about that, and I don't know if I have these figures quite clear, but the average Canadian building looks to be 572 kilowatt hours per square meter of floor space. Is that right?
Correct.
And
per year.
And per year. And your client, which is an energy company, they had a reference building that that came in at what, 258, so about half of that as a reference, and you came in at 91 kilowatt hours per square meter as modeled and 88 and as a projected figure, which is amazing.
Yeah, it's outperforming the model. I mean, TransSolar have very sophisticated software that could basically tell Manitoba Hydro what the comfort level would be anywhere in the building at any time of the day, at any season. Really remarkable stuff. I mean, I've seen a lot of modeling that's been done, but they create their own software. The building is actually outperforming because it's being very closely monitored right now. I mean, every aspect of it, it's, you know, now that the building is open, a whole new chapter of really looking at its performance and studying its performance over time is really taking place. And what we're finding is that it's outperforming the model. We were shooting for 60%, and we're getting closer to 65. Plus, I think what's amazing, I mean, these may be ordinary things, but the two things that people are really talking a lot about, I mean, they love the building, but the two things that people constantly talk about are the quality of light and the air quality. It's so basic, light and air. A lot of people have allergies and asthma. And those people particularly think our building's really fantastic. They've never worked in a building with that much fresh air. It's displacement ventilation, fresh air, 100%, coming from the floor. It's like a European building. And then we have the dynamic thermal slabs, 20 degrees Celsius, whether it's minus 35 or plus 35 outside. In the shoulder seasons, which there are, even in Winnipeg, there are transitional seasons, we go natural mode, hybrid ventilation. We have a solar chimney that is really a European concept, really. It's like a fireplace chimney. It's drawing that fresh air that comes in through the floor, hits our bodies, warms up, plumes, stratifies, and is drawn very slowly across the ceilings of the office spaces to the north end of the building. In the winter, we capture that energy, we heat the garage. In the summer, we let it go, we exhaust it. And what I've learned is it's not one thing, it's a combination of these systems, which have been carefully modeled, that are all working together to really make the comfort level that this building is enjoying right now. And we're getting great feedback from employees, people who just work there. You know, the best story was there's a VP who was ready to take early retirement and has been so inspired by the building, he's hanging around. He said, this is great. He said, the only problem is we didn't do it 15 years ago. And these are the little stories. You say, well, that's just an anecdote. But these anecdotes add up. And they add up to the performance of the building at the level of the people who are actually working in the building. And so they've rediscovered working downtown. They're saying they're riding buses now, 50% ridership now. They were in the suburbs before. This is nothing but a city building project. It's kind of, you know, if you take 2,000 people and you put them into a city that needs downtown revitalization, something's happening. All the restaurants, there are 45 restaurants in 4 minutes of the building. We did not put in a big cafeteria, nor did we put in a food court. I mean, these are planning decisions that actually affect how this building affects its surroundings, and I think we made a lot of really good ones.
I'm told that people in Winnipeg call this the open book building.
That's interesting.
Because of its shape.
Yeah.
And describe that for me, because you've got kind of a wider aspect, probably to the south,
yeah,
to catch the wind as it comes up.
And the sun. See, the reason it's formed like that is because the wind is coming from the south, so that's where we're getting our fresh air. It's just naturally, like it wouldn't work as well if it were facing north or west or east. It works perfectly when it's facing south, plus all the sun is there. So that analysis led to this idea that you could make an east loft and a west loft and spread that open so that there were two pure column-free loft spaces, and everything down the middle of the book drives the environmental performance. So the cores, the washrooms, the atriums, the solar chimneys right down the middle of the building. So it's also been described as a capital letter A, and so it's a very clear organization for a building. It's actually two buildings, east and west, and they're joined.
So summer and winter mode, we've kind of talked about summer mode here in that you have the air coming in from the south.
Yes.
And then the winter mode, you have this, the solar chimney that you mentioned that uses the stack effect, which anyone in a building with elevator shafts is going to know what that is, with the wind rushing through there. And that's part of the winter mode, is that right? And winter mode is what exactly?
In the winter mode, what we do with the warm air that's coming out of the office space is we draw it downwards with fans and we heat the garage. In the summer, we let the solar chimney do its job and just open up the top of it. We also have an incredible, really incredible preheating function, which is passive. We have at the top of the tower a steel frame, and in that, there are probably, I don't know, I want to say 160 hollow section steel members that are grouped almost like a carillon, and they're painted black and they're filled with sand. And in the sunlight, they heat up. They get really, really hot. They get up like 30 degrees Celsius. And it naturally preheats the flue. So warm air rises. And so that's another way where we even do the preheating function passively, which I think is really, really inventive and part of our overall energy reduction strategy.
What I was going to ask you about the solar chimney to make sure that I understand this is that you are pulling warm air, which tends to rise, of course, back down through the building and then out the bottom, so you're recirculating the warm air that's
it's basically a
already
heat
there.
Recovery of that warm air, and only in the winter. And we don't have a lot of parking, because one thing Winnipeg has is a lot of parking. So this project is all about understanding the context. That's why I like this award. It's urban habitat. That's why we think we're doing something significant, because we also organize the building in a way that creates 3-floor neighborhoods of work, all organized around 3-story atriums, and 2 of those linked to the south atriums. There's a kind of prototypical section that's 6 floors. When the 6 floors faces south, it's high enough to get the stack effect in the south lung of the building. And at the north end, we have 2 3-story atriums, which are very comfortable. They have interconnecting stairs. I mean, the worst thing in a high-rise building, I think, is to stand, wait for an elevator if you're going 1 floor up or 1 floor down. I think that's a real waste of energy and other people's time. And I think this building is structured, the base building, so that those interconnections are occurring at the south end of the building and at the north end. So you could be part of an engineering team that uses that stair.
I think one of the most interesting things about this is, for those of us who live in cold climates, is you have the tendency in winter when the weather gets cold to just kind of close the building up and just kind of button down and, you know, stick it out during the winter. And this building indeed does breathe and is open to a certain point. Even during the winter, it breathes that way. Is that right?
Well, the double walls, if it's minus 30, those windows aren't opening. They're acting as buffer zones. It's like 2 layers of glass, outboard, 1 inboard.
Okay.
And the building management system won't allow those windows to open. But the fresh air is always coming in naturally. If it comes in at, say, minus 20, we'll preheat it to probably 12 in the south atrium. It'll still stratify, still come into the building, and it'll still interact with the heat that's generated by people, by computers, and by lighting, stratify. And so the winter mode is relatively buttoned down in the winter. It's sort of in the summer when it can really open, and in the spring it can really open up.
And the term for this was kind of interesting. It was biodynamic double facade windows
Yeah.
that open. Biodynamic being what exactly?
Well, that it's really related to the climatic conditions. Like the building management system is smart enough to say if it's really cold or really hot, those windows aren't opening. It's being responsive to what's happening outside.
There are, I guess, a considerable number of winter gardens and waterfalls in the building, which, as we've observed on a number of occasions, that in the past, building developers wouldn't devote so much square floor, so much footage or square footage to something like that. I guess in a building like this, these are really a necessity. First the winter gardens and then the waterfalls. Tell me about the winter gardens and what functions those fulfill.
The waterfalls are essential to the humidification and dehumidification systems, but they're visible in the atrium. So there we have, again, this amazing system. It's 188 strands of mylar, 6 floors in each 6-story atrium. And water is filtered, recirculated, and comes down, adheres to those surfaces, and comes into a pool of water. The surface area is calculated by our Transolar friends so that that dry winter air is picking up that humidity before it goes into the raised floors. In the summer, we chill that water, so the humid, hot air coming into the atriums condenses on this instrument, but it's also extremely beautiful. So that, to me, is the future of design, where the performance of the element and the aesthetics of it are so integrated that they're just one thing. It's not like, and by the way, that's the sustainability feature. I mean, and this is architecture. It's, everything is coming together. And I mean, I really think that's the best part of this project, that it really is a fusion of science and art, of engineering and architecture, of landscape and city building. And we always said with Hydro that, why are you doing this project? The reason they're doing the project is for their creative workforce. They have 2,000 people. They want to attract and retain the smartest and the best, and they want to create a healthy and productive workplace environment, because they, more than anyone, know that their biggest asset, more than real estate, more than energy costs on an annual basis, are their people. That's why we did the building. We did not do the building to achieve a LEED Gold or Platinum. We'll get a LEED Platinum. We did it to reduce the energy costs, for sure. But what we really did it for was to create a healthy workplace for 2,000 people.
I was going to ask you to describe the client some, and you already have. What was their overall goal with this building? What were you told at the outset about what they were wanting?
They wanted the energy performance first, and they wanted to balance it out with workplace design, city building, signature architecture, and cost. But they really wanted the energy reduction. In fact, had we not achieved 60%, which was their target, I think they would have considered this project not successful. I mean, we all were talking about it. I said, well, what if we don't achieve our goal? You know, it'll still be a good project, won't it? But I could tell by their body language they didn't think it would be a good project.
That was not the right answer.
That was not the right answer. But you know, now everything's worked out. They're living in the building, and they're realizing that they've got something that is outperforming the model, and it's actually really showing the workforce, the people who work for Hydro, a completely different way of life. I mean, this is one of the projects which has shown me that architecture and design has the power to change the way people think about work, how they actually work, how they think about the city, how they actually interact with the city, where they spend their time. They actually go out and have lunch in these little restaurants that are all around, you know, the downtown. And I think the downtown is a much better place because they're there. It's safer, it's more animated. You know, it's just a better place, and that's what Winnipeg needs. So it's not just about Hydro, it's about the city of Winnipeg. The city of Winnipeg is like 666,000 people. It's not very big. The province is 1.2 million people. That's not very large. And they've gone way out, and I think they're able to do that because, and they should do it because they are a crown corporation, and they've taken public leadership and really demonstrated something that no one else has done. They've created an exemplar. You know, and everyone wants to kind of inch ahead. Well, they actually just leapfrogged, and they went right to the top of the pack, and they actually are demonstrating something that a lot of the rest of the world is very interested in. A lot of interesting calls are coming in from Asia, China, for example. People have caught on to this building and said, what is it? What's going on? They want to know more about it. Russia, you know, cold weather climates, right? But I think what I learned was it's the process. It could be in any climate. It's the integrated design team. It's the balancing out of goals, not one thing at the expense of everything. And how do you fuse it together in an integrated solution where architecture isn't the be-all and the end-all, height isn't the be-all and the end-all, energy isn't the be-all and the end-all. What is the be-all and the end-all is the comfort level for the people who actually have to be in the building and the city. I think that's pretty much a top goal as far as I was concerned.
What I was going to ask you was, obviously, this could be a template for other buildings across Canada and the world, but when you talk about humidity control systems, and particularly a waterfall or some device that humidifies and dehumidifies, boy, it gets awfully humid in the central part of the continent. I don't know if Winnipeg has quite the humidity issues that.
Oh, huge humidity.
Okay, and
Unbelievable.
certainly places in Asia do, and a system like what you described would be, it sounds like, more than up to the task of dehumidifying, because that's so much energy cost right there.
I think that piece of it may have application elsewhere, and I think you can see other buildings that use similar technologies, but the real lesson, the real message is that every place in the world has a different climate, and the real message is you have to know that climate, know the potentials to be passive within it, and look at buildings that were pre-air conditioning to see how vernacular culture is actually built within those different climates around the world, and have an integrated design approach to designing anything. So it's not just technology transfer and, you know, we'll use this over here. I think you have to see the climate first, the people and the climate, and then build out, and then find the right technologies.
So based on what you've learned, the many things that you've learned from doing this building, some of which I'm sure came as a pleasant surprise, any new ideas of things you'd like to try on future versions?
Well, what I'm realizing is that every climate is different. So where I'm from, Toronto, is very different from Vancouver, you know, where they have a lot of overcast sky. They don't get as much sunlight as Winnipeg, and you have to think differently. You have to find what are the specific strategies that could be pulled together in an integrated way that will really make a more passive overall approach to heating, cooling, and lighting in each of those regions. And they're all different. Like, you couldn't transport Hydro's building into Toronto and say it'll be successful. It won't. We don't get the same sunlight. Our prevailing winds are from the west and northwest. It wouldn't work. And I think that's the biggest mistake people will have with the building. They'll say, oh, we need one of those. Well, you don't need one of them. What you need is the knowledge and the way to think about how to make a form that relates to its context and its geography. One of the great things about the citation is, I think they said this could only be, it was so specific to Winnipeg. It was so specific in that it was a seamless integration of the considerations of sustainability, architecture, city building, and the social well-being of the occupants. Like, that for me is, that's exactly what it's all about. That's what's transferable to another location, that attitude, that way of looking at things, not the specific form.
And you have a system or a set of tools here of various things that I guess can be scaled and used individually based on the situation, that can be adapted anywhere.
Yeah, and I think, I mean, part of the...
even in Russia and even in humid
yeah,
Asia.
a lot of them are European products, European systems, but I think a lot of people, the innovation is pulling together things that work, but put them in combination and use them appropriately as applications. But the truth of it, the core of it, is that, and everyone will tell you, if you really want to make a building that's really environmentally sensitive and really strong in terms of energy reduction, the very physical massing of the building and the orientation of the building is critical, is so critical that if you get that wrong, you can do everything else and you'll never get anywhere. Okay, that's what I learned. That the form of the building, the orientation of the building, drives the performance. And then there are all the technical systems that are laid onto that.
Manitoba Hydro Place in Winnipeg is the winner of the Council on Tall Buildings and Urban Habitat 2009 Best Tall Building Award for the Americas, and Bruce Kuwabara is a partner at KPMB Architects in Toronto. Thanks for talking with us.
Thank you very much. Thank you.